All right, guys, we're going today to get started on partitioning a line segment. Before we do that, I just want to give you the answers to your warm-up. This is just review material. Finding the distance between those 2 points would be the square root of 226 units. Our slope of this line, slope is m, equals a negative 3/4. The parallel lines have the same slope. And our perpendicular line is going to be opposite signs, so this is going to be positive, and a reciprocal. So instead of 3/4, it would be 4/3. That would be the slope of our perpendicular line. On the area and the perimeter of the triangle here, remember our area is our base, BC, times our height, which is our altitude. So from the vertex A, perpendicular to the base, BC, is 4. So your area would be 6 times 4, which is 24, divided by 2. So you would have 12 units squared. The perimeter here would be your base of 6, plus then you would use your Pythagorean theorem to find the length of AC, which is going to be 4√2. And then Pythagorean theorem to find the length of AB, which is going to be 2√5. And this would be your units, in units for your perimeter, straight units, not units squared. Now remember, this could be in any order. You could have 4√2 plus 6 plus 2.5. Anyway, addition is commutative. Okay, so let's get started. Partitioning a line segment. To break it into parts. That's what we're going to be working on today. Okay, the first thing I want you to do is understand the difference in ratios. We want to know what it means when we break a segment into ratios. So this ratio right here, 2:5, means 2 parts to 5 parts. And we want to think about how many total pieces that is. So if I have 2 parts, and then I have another 5 parts on the other side, just forget about this, then I have my ratio be breaking it right here, breaking the segment right here, 2 parts to 5 parts. And that gives me 2 plus 5, which is 7 total pieces. 1/3 or 1 to 3 parts is written as a ratio as well, like this. Another way to write it. That's 1 to 3. And just like above, to get our total number of pieces, we would add these two. And we can check it down here. So if I say there are 4 total pieces, let me break this into 4 pieces and see if I can make that ratio. Don't worry about these numbers. I've got 4 pieces. Can I break it into a ratio of 1 to 3? Well, here's 1 part. This is where I'm breaking it. And there are indeed 3 parts on the other side. Now, let's talk about the difference between a ratio and a distance on a line. So this problem right here, I'm going on an 8-mile jog. That means it's 8 miles from one end to the other. So I'm going to break this into 8 pieces. Now, what point represents 6 miles into the jog? So that'd be 1, 2, 3, 4, 5, 6 miles would be right here. Doesn't like when I try to write too small. So that's 6 miles. So the ratio, what is the ratio? Parts to parts. I have 6 parts on this side and 2 on this side. So my ratio would be 6 to 2. Now, how far into the jog? My distance. My distance is going to be that I have gone 6 out of my 8 lengths, which when simplified is 3/4. So I am 3/4 of the way through the jog. That is my distance. So my ratio was pieces to pieces, and my distance is how far out of the total. Over here it's easier before you look at the simplified. How far out of the total? Your total is always going to be adding these two pieces of your ratio. Now on a 30-mile trip, we're going to just say that this is 0, and this is 30. X is at 0, Y is at 30. What point represents 12 miles into the trip? I'm not going to do all the lines. I'm just going to pick one and say this is 12 miles. And what is the ratio? Well, I have 12 parts on this side, and that would leave me 18 on this side. Now, how far in the trip are you? Well, I've traveled 12 out of my total 30, and I can simplify that. So I've gone 2/5 the distance. Thinking about the difference between a ratio and a distance. Okay, these are some of the formulas we would use for partitioning a line segment, and I'm just going to go over my favorite formula that we use, which is this one. I'm going to tell you what everything means. Then we're going to get into our next little video where we're actually going to start using this formula. So this XY out here, I'm going to label this as point P, and it is my partitioning point. It is the point where I break the directed line segment. This X1 is my starting X point. Starting point X value. This right here, it's interesting. The A over the A plus B. When I write a ratio using this formula, it's in the form of A to B. Remember when we did distance, it was always the part out of the whole. So it would have been the part out of the whole. So this is really just my distance. And you'll see it again later. This is separated by a comma. I'm doing the X's on one side and the Y's on the other side of the comma. So we'll use the distance twice in this formula. So that's my starting X point, my distance. This looks very much like your slope, doesn't it? Or not your slope, your run of your slope. And it is. Sorry, this right here is the same thing as the run of your slope. So this is going to still be my starting X value. And this is my X value from my ending point. After the comma, we start all over again, where we have the Y value from the starting point we again add our distance times our rise. This is a run, remember? And this is our rise. So that's my starting Y. And this is the Y value from my ending point. It looks complicated, but with a little bit of practice, it's pretty easy. Don't forget that when we work with the formula, we're going to take our distance and distribute it to our run or our rise, and then we would add it to those starting points. All right, guys, in the next video, we're going to use this formula, so have it written down with all of these descriptions and be ready to use them on some practice problems. See you in just a bit.